Work it, make it, do it, make sense.
My name is Stephen Fluin. I am a developer advocate on the Angular team at Google. My role on the Google team really has two parts. The first part is to help developers and organizations be successful with their use of Angular. And the second is to really understand what it's like being a developer out in the real world, building applications every day, and then reflecting those needs within the team to help make sure that we're making the right sort of product decisions. Today, we're here to learn a little bit about RxJS and how it works with Angular. So we're going to go through basically 4 parts. We're first going to talk a little bit about how Angular works, make sure that we're all on the same page. Then we'll switch over to talking a little bit about what RxJS is, what the problems it's trying to solve are. And then we'll talk about how they come together to solve a lot of kind of problems in a new, interesting way. And then we'll actually do some live coding so that we can see how some of these things come into play in the real world while building an Angular application from scratch. So before we get started with Angular, I want to get a little bit of a survey or poll from the audience here. How many people have used AngularJS? So that is the 1.x version. All right, almost everyone here. Now, how many people here are using Angular, meaning versions 2 or later? So if you're on the latest version, you'd actually be on version 4.1.2, I believe. What we're seeing is kind of a huge adoption across the community of both these frameworks, and they both continue to grow. But we're seeing a huge uptick in Angular, and that's a term I'm going to use very intentionally throughout this presentation. So as we think about Angular itself, I use the words, Angular is a platform that makes it easy to build applications with the web. And I want to call out several of the words here in particular. So platform. What I mean by platform is that we're really trying to move beyond just being a framework into solving all of the developer experience problems that you have to face and you have to overcome when you're building an application. I also say building applications because these applications can be running kind of anywhere. But at the foundation, we're still using web technologies, right? We're still using JavaScript. We're still using browser rendering engines in some cases. And so just understanding kind of how we look at things really should help you give a little bit of a background, a better understanding as we proceed here. So this is actually a picture from a dinner that we had the last time the team was in London. So this was in November of last year for Angular Connect. And I love this picture because Miško, the founder of Angular, is sitting there in a chair. And when Miško created AngularJS for the first time back in 2009, we were really trying to solve a very unique problem. The web was rising as a platform for building applications, but it was a little bit tough, right? We had things like jQuery, where you could make single manipulations to the DOM. And so he asked the question, if we could build applications any way we wanted to, how would we want to build applications? And so that was some of the philosophy that went into AngularJS the first time around. Then the other half of that is really focusing at how do we solve problems at scale? Right? Miško worked for Google, and so when we try and solve problems, we don't try and solve them for a few users, we try and solve them for all of the users, right? We're trying to address millions or billions of users. And so that was sort of the foundation of how Angular was created. And so when I flash forward to these days and we look at Angular, I really think about 3 kind of core values or things that we care about when we're thinking about the platform and how it involves our users and developers. So the first thing is we want applications that users love to use. Second, we want applications that developers love to build. And lastly, a community where everyone feels welcome. And that last piece is very important to us because community is an essential part of what we do on the Angular team. We would not be successful without the huge numbers of libraries, tool sets, seeds, components. All of these things that the community creates and offers up to each other makes Angular what it is and makes it very powerful. So one of the things that we look at is actually some data from the industry. So back in 2016, GitHub did a state of the Octaverse, so looking at and understanding the open source projects that existed on their platform. And you see here that Angular was actually one of the top projects by numbers of contributors, even above the rest of Google, which is a little bit funny from our perspective. Another study that we take a look at, it was actually the Stack Overflow 2017 survey. And they looked at different frameworks and libraries that were being used out in the world, and people were engaging from a standpoint of asking questions, as well as developing and answering and solving issues. And so they bucketed AngularJS and Angular together. And according to their numbers, AngularJS and Angular together are the biggest framework or most used framework according to everything that they're seeing. And so this sort of momentum is kind of very important to us and important to you as developers because you really rely on that ecosystem. As we look at kind of the more technical side of things, why people like to use Angular beyond just the community, we see many features that we've built in, but kind of some of them are baked much more into the core of what we do. The first is dependency injection, which I'll talk about a little bit. Then we've got single pass change detection, so how we actually operate change detection, which is now distinct from how we did in AngularJS. Then we'll look at declarative templates, which have the same sort of philosophy that we've always had. So the first one, dependency injection. Dependency injection is a standard topic. We didn't invent it. We just leverage it extensively as part of building our platform. But the way I think of it is really just access to the services layer where and when you need it in a very clean, very stable way. Back in AngularJS, unfortunately, we actually had to hang a lot of those things basically into global scope. Whereas when we look now towards how we architected Angular, there is nothing being polluted in the global scope in production. Everything is enclosed. Everything is relative to your imports, relative to your files. And so it's a much cleaner way of getting access to the services at any point in the application where you need it. But because you're able to refer to things by types that are being imported from their files, we know exactly what you're importing, and we can be very intelligent about it. Another thing we did between AngularJS and Angular was we reworked how change detection works. So in AngularJS, basically we would look at all of the expressions in your entire application, and we would run them all. And then at the end, we didn't know if something had changed because of change detection that happened in one place, modifying something else, and so we ran it again. And what we actually do is we would run this digest cycle over and over and over for developers until things stabilized. And this meant that when you were building very large applications with maybe thousands of things on the screen, runtime change detection actually ended up getting very slow in AngularJS. And so this is one of the kind of main drivers behind our move over to Angular, which was a rewrite. So in Angular, what we see is that our entire application is built as a graph, a single graph, that we can do a single pass of change detection. So we start at the top, the root component, and then we can go down the tree based on the current state of the application and evaluate each component individually and say, hey, what has changed here? And we're so confident that this is right and this is the right way to do it that when you're in development mode, we'll actually run change detection exactly twice. And if anything changed between the first pass and the second pass, we'll actually tell you and we'll throw an error saying, hey, you had an unintentional side effect of your change detection. You should go back and look at this because this is an error case. The last piece that we really feel is fundamental to what we do in Angular is this idea of declarative templates. So we're all very used to, as AngularJS and Angular developers, writing in HTML and then adding this special syntax, which is still valid HTML, that makes it easier to interact and express what do I want to actually see from a view standpoint? What do I want on the screen? And if you compare AngularJS and Angular, we've actually dropped something like 50 of the directives. We're really trying to focus on making things much simpler. And so in Angular, what you'll see is things like text interpolation, where you can use the double braces here. So person.name is person is an object on our or a property of our component, and we can get the name subproperty of that. But we can also call methods within text interpolation. And we can also use this within attributes as well. But a little bit better than that, a little bit cleaner. In AngularJS, we had a number of different directives like ngcloak, nghide,ngshow. As I said, we reduced and removed a lot of those. And what we've replaced them with is this very simple bracket syntax where you can bind to any property on a component just by using the same syntax, whether that's an image, whether that's an input, or whether that's a custom component that you have built yourself. So there's many things that we're kind of more opinionated on. There's some things that we're less opinionated on. So from a freedom and from a choice standpoint, we're a little bit less opinionated about data. So data is very core to what we do on Angular, but we're trying to expose a lot of different great ways to interact with data. So on one end of the spectrum, you've got things like HTTP, which are going to do arbitrary fetches of endpoint data using XHRs under the hood or fetch under the hood or whatever the technology you want to use there is. On the other end of the spectrum, we've got integration with real-time databases such as Firebase. We also have community members who have built things like Apollo, which is a way of declaratively pulling in data from GraphQL backends. Where you can, in any of your components, simply state, here's the data this component needs and what I want it to look like. And then Apollo will aggregate and combine all of those queries into a single query to the backend. And then all that data will come down at once and then get parsed back out into all the components that needed that, which is a very cool way of building applications at scale. We're also a little bit less opinionated on bundlers, although this is continuing to change. So when we first released version 2.0, our CLI, for example, was using the System.js bundler. But what we found was that there was still a ton of configuration work that developers had to do. And so you can still build and run and bundle your application using whatever bundler you want. But many of our developers and a lot of our tooling is moving towards Webpack. But what I say is that we're still going to continue to be less opinionated of the bundler, and that our CLI actually under the hood does not expose any of those capabilities that come with Webpack. And that's intentional. Our CLI is a little bit of a black box. And I said that this was intentional, and we do that because the bundler systems that exist today are going to change over the next 12 months. So finally, we have ES 2015 modules landing with native support in the browsers. But this native support works a little bit differently than how all of the bundlers have implemented it. And so as the browsers continue to evolve and change, and as search engines start to implement this same sort of features, we're going to see all of our bundlers are going to want to react so that we can maintain some level of compatibility between the code that we write for a bundler and the code that we write natively for the browser. Another thing that we're a little bit less opinionated about is how to ship great experiences for mobile. We're less opinionated because there's lots of great ways to do this. Again, on one end of the spectrum, you've got things like progressive web applications, where we're shipping to native browsers that have these enhanced support for things like service workers, allowing you to basically, in a very simple way, add a service worker that proxies all of the HTTP requests that the user makes to your application. And in doing so, we can make your application work offline, we can make it work instantly, and we can give you complete control of the balance of performance and freshness that you want for your application. And there's also installed mobile. So if you're still looking for an experience that is installed onto the App Store or into Google Play, there's things like Ionic, which are frameworks built on top of Angular that are really designed to make it easy to have that installed experience. And they use Cordova under the hood. But there's also technologies like NativeScript from a company called Progress, or formerly Telerik. And NativeScript is the idea that because Angular is no longer dependent on the DOM, because we are no longer having to run all of our template compilation in the browser, we can actually do all the template compilation and compile to a different target. And so, for example, with NativeScript, their target is native mobile widgets. So on iOS and Android, you write NativeScript instead of HTML, and then you compile to these native widgets that are performant and have that native look and feel out of the box. So those are some of the things that we're less opinionated about, but we're more opinionated about a few things. So template syntax, so a very similar template syntax to what you saw in AngularJS is everywhere in Angular. We're also very opinionated about our rendering pipeline. This idea that instead of doing all this rendering in the browser and making the user's computer pay that cost, we want to do all of the compilation on the build time on the developer's machine so that we save that time and we can make the bundle hopefully a little bit faster to run. Another thing we're a little bit more opinionated about is the use of TypeScript. And so you can still use Angular with ES5, ES 2016, but there's a few places where TypeScript is going to get you huge advantages. So for those of you who don't know TypeScript or haven't started using it, TypeScript from our team's perspective is really just the latest and best from the ECMAScript standards. So whether that's ES 2015, ES 2016, 2017, and beyond, TypeScript automatically takes all of those standards and includes them out of the box with their compiler. And then on top of that, it adds something that really makes it easier to work on large teams or on scaled applications, which is types. And I'll come back to types a little bit because types make working with asynchronous data a lot easier. So we're all used to having callbacks and promises and all this data that's going to come from somewhere else at some point in the future. And if you can have types that follow that data, that can make your world a lot easier. And then the last thing that I want to talk about, the topic that we're going to dive into today is RxJS. And so we're relatively opinionated about RxJS because we actually use it in Angular, and we expose a number of different ways for you to use RxJS within your own applications. So let's first get into a little bit of a background in terms of the problems that RxJS is trying to solve. So I say that RxJS is really about bringing functional programming principles to JavaScript. And you might say, well, why do we want functional programming principles? And so I'm going to take us on a little bit of a journey. And so all of this journey kind of starts with the rise of asynchronicity, where we've got data that is flowing through our application coming from a number of different places. It can come from APIs, backends, it can come from different WebSockets, it can also come from user-triggered events, and also things like timers. So all of these things are coming in, and we don't control when they happen. We don't necessarily control the order that they happen. And so having a more functional paradigm can help us with that. Let's take a look at some of that a little bit further. So you really want your applications to be more predictable. But as soon as we start scaling these applications up in the client side in an area that we can't control, if you don't use a functional paradigm, they become less predictable. So here is a brief egregiously oversimplified, totally incorrect history of JavaScript. Just a disclaimer, all these concepts are older than me. I'm just talking about the rough timeline that developers have started to adopt them when we build web technologies. So in the beginning, JavaScript was a weekend project from Netscape, right? It had a single thread. It made a few things move on the screen, and that was great. But we live on the internet, right? We want to be connecting to data. We want to be connecting to other users. And so we couldn't really just rely on this single-threaded, all-running local set of JavaScript. And so we really had the rise of the XHR. And so this is, hey, I'm going to make a asynchronous request. I'm going to go get some data. I'm going to pull that back in. And that worked great, right? We've added XHRs throughout our application. And so I've taken something that maybe was simple, like do process, and now I've given it a callback, right? So now I'm saying, hey, when you get this asynchronous data back, do something with that. So take my success parameter. But it's never actually that simple, right? We also need to handle the failure case. And so these callbacks got more and more complicated. And so what was kind of at first a beautiful structure of XHRs, now it's starting to look a little bit wonkier. It's a little bit harder to maintain, a little bit uglier. And so then we had the rise of promises. So promises were going to solve all of the problems that we had with XHRs, right? So instead of having callbacks, we now have this beautiful painting, right? We have, I'm going to say, give me this single set of data, so http.get from Angular.js here, and I get a result that I can then call a then method, I can call a catch method, and I can do these asynchronous operations on in a way that feels more declarative, it feels more natural. But then what ends up happening is these start looking a little bit more and more like callbacks, right? We have a then method, we have where I'm handling the success, I have a catch where I'm handling the failure, and then these end up causing a few problems for us. So the promise is defined where the data is created, right? Not where I'm consuming it. And so what if I wanted to retry a failed call? Then where I'm consuming the data, I actually have to know about what's happening over in the creator of the data, and I have to have a mechanism for passing information back. And that mechanism ends up being all over the place within our applications, and we don't really have this nice one-way data flow, which really makes our beautiful paintings look a little bit like this, where you've got paintings on every surface of your entire application, and again, it becomes a little bit hard to manage. So from one perspective, RxJS is all about unifying the ideas that came from promises, callbacks, and all these data flows, and making them easier to work with. So the fundamental principle that you need to know about in RxJS is called an observable. It's just like an array, but if you think of an array as being in space, right, on your memory, observable is a sequence of events over time. And that sequence of events can be anything from nulls or undefined, like it can contain no data, all the way to having a complex object or a Boolean or whatever you want to put into these sequences. It works just like an array. So when I think about observables, when I explain observables to developers that have never worked with them before, there's really kind of two participants. There's someone that creates an observable, a data source, and then a subscription. And then observables, the interactions with the observables, are all about how do we map the data from the source to the subscription to where I'm actually consuming that data. And so in Angular, we have an HTTP library that's been relatively straightforward for a lot of developers. So we have an http.get method. And so what this does, instead of returning a promise, we now return an observable. And so I say data equals http.get, and I refer to my API. So now data is going to be an observable of responses. So that's the creator. And then on the subscription side, I actually want to consume that data. I can subscribe to that data. And there's three things I can do with that data. I can, every time a new value is being emitted, I can get that value via the next method there that I'm creating. I can also see if there's any sort of errors, and then I can see when the observable is done emitting value, so when it is completed. And then, as I talked about, we've got on one end, you've got the creators, and then on the other end, you've got the subscriptions. We also have a number of really useful operators. And what these do is these define basically a function that happens on an operator when it's being consumed. And so the simplest one that we use all the time is called map. And so what it does is it takes, you have the map operator on an observable, it takes in an item from the sequence, and then you can do whatever you want with that. So if we have an observable that's giving us a set of people, or a list of people over time, we can actually say, hey, turn this from an observable of people into an observable of their names. And that becomes very useful because I can define that stream, but that stream actually doesn't run unless someone is listening. An observable is not activated until someone activates it. Another thing you can do is at the point of consumption of an observable, right, where you're subscribing, you can actually say, hey, if this fails, retry this. And so you can compose these observables via various operators to make them much more interesting, because I can now, via that HTTP, for example, even if the HTTP was originally created in a service that's 10 miles away, I'm in my component, I want to actually do something with this data, I can say, hey, retry this if this doesn't work. And that knows how to operate all the way back up the observable chain and re-emit those values or retry those attempts. As I mentioned, there's this idea of hot and cold observables. So cold observables are just defined, right? You're defining the functions, you're defining the streams that are going to exist in your application, but they're not actually activated until you subscribe to them. And so let's take a look at how Angular and RxJS make things better when they're coming together. So the first thing that we've done is we've built a pipe called the Async Pipe. So basically everyone that uses Angular is going to end up using this pipe at some point. So while you can do a standard subscription within your component, right, where you can say, hey, I manually want to start looking at this data, you really don't want to. As much as possible, you want to be doing this in the declarative template style that we recommend. And you do this with the async pipe. And what the async pipe does is, whether you give it a promise or an observable, we're going to create a subscription. We're going to unroll that asynchronous data when the component is loaded, when that piece of the template is actually running, and we're going to automatically unload it as soon as that component is torn down. And so this manages the whole life cycle of subscriptions to observables, so you don't have to be managing any of that yourself. You're going to find observables pretty much everywhere as an Angular developer. So you're going to see this in many libraries. So I'll look at Angularfire 2, and I'll also look at NGRX store, which is a Redux-style pattern that we've got. And then we also see these things within Angular. So let's start talking about Angularfire 2. So how many people have used Firebase before? All right. So Firebase is, it started as a real-time database, but these days it's actually a number of different things. So Firebase is now, it still has the real-time database capabilities, but it also has things like file storage. Firebase has things like hosting, authentication management, as well as event management. So it's kind of become a much broader developer platform. But when you use Firebase for authentication or databases within Angular, you're going to see that data come in as observables via the Angularfire library that connects these two things. So here's an example where I'm defining on my component an items property, and that items property is an observable with a list of items. And so that's a sequence of lists of items. And so in my constructor, I just pull an Angularfire and I say, hey, go get this list of data from the Firebase real-time database. And then I can save that as items here. And once again, this doesn't get executed. This doesn't actually get run until I subscribe to that data. And so I can create as many of these as I want without any runtime penalties or cost at all. But then, when I want to actually use that data, it's very straightforward. I can use it iterable by ng4, and I can say let item of items from the async unrolled version of that. And then I can access any of the properties, such as the name of every item there. I also mentioned that we have authentication integration with Angularfire. And so this is a very common use case where I want to, for example, get data about a user. And so I'm going to be combining both the data coming from the authentication layer with the real-time database layer. So I'm using an operator called switch map. So what this basically means is every time data comes in, every time authentication data comes in from Firebase authentication, that's events like logging out or logging in or having some sort of change to my permissions. I am now switch mapping, which means I'm getting a sub-observable and returning the items emitted by that sub-observable, where here I'm getting the actual data for that user. So my auth state is coming in because the user logged in or logged out. And then if they did log in, so I've got a state, then I can actually use something like their UID and then fetch the data from the users table. And so this gives me a single stream that is always going to be either a null or a full set of user data, combining the best of the database lookup and the authentication layer. Another great library that exists with Angular is called NGRX store. And so if anyone's familiar with the Redux pattern, this is basically that same sort of capability built within Angular. And so if anyone's familiar with that pattern, it really has three things. It's got a store, so it's a single immutable data store that we're going to add data to on top of as we change or as we add information. We've got something called actions. So anything in the application can emit an action, such as increase counter, decrease counter, et cetera. And then we've got reducers. And these three things come together in a relatively simple way. And so I can, for example, pull out of my store a counter. So I'll do store.select counter, which, because of how NGRX is built on top of observables, is going to give me the latest data from the store from that counter object. And so we were looking at the combination of reducers that create new state from old state plus actions. But I, as a developer, once I've created those actions, once I've written those reducers, all I have to do is point at the data I want, and I can know that it will always have the latest and freshest data that I need. But it's really beyond libraries. We've actually baked RxJS into several places within the core of Angular. The first place I want to talk about is the router. And so if we think about a sample application where we maybe have two routes, so we have a default route that goes to our home component, and then we have a route that goes, if the user goes to posts/42, that will pull up our view post component for rendering that item. And so we use observables here to express those route parameters. You can also get them synchronously, but there's some problems with that. So let's take a look at what we're doing here. So we're taking in this observable of parameters. So anytime the route changes, we're going to see a new emission from the router with those parameters. And then what I can do is I can return another observable from maybe a service or from Firebase that fetches the data for the specific page that I'm on. And then I can also use an operator, something like do, if I want to do additional actions whenever this operator is being run. And so the reason that we made our router use observables rather than synchronous data is because we wanted you to be able to reuse your components. And so what that means is if you go from posts/42 to posts/43, we don't actually reinstantiate the component at all. All we do is we emit a new value from the route parameters, and then you can decide how much of the state you need to tear down or build back up. So it's really all about runtime performance there, where we can reuse as much of the application, reuse as much of the state without having to run extra cycles of change detection. You can also do very fancy things. So I know this is a very complex example here, but I'll try and explain it a little bit. So all of the events that happen on the router come as an observable as well. And so this is a sequence of events over time. And what I can do is I can use something like this filter operator, which gives me a subset of those events. So we're checking every event and saying, is this a navigation end event? So did a user successfully navigate to a route that they were interested in? And then I can subscribe to that. And then what I do is I know, because of typing, these are all navigation end events. And what I can do is, for example, send an analytics request out if I want to save that a user hit that state. Or maybe I want to look into the router configuration that exists within my application and render a page title that was set up declaratively. So I can set up all of my routes ahead of time. I can say right next to the URL that I want for it what the page title I want was. And then this kind of few lines of code in my app component will automatically listen for all those events and then dispatch them as appropriately to the title service, as well as to anything like analytics. HTTP is also based on observables. And so an HTTP by default is only going to return exactly one item, and by default it returns a response. And so most commonly what we're going to do is we're going to take that response and we're going to get that body. We're going to get that body as JSON out of it. And so you'll map from response to response.json. And a lot of people ask me, why is HTTP an observable if you're only going to return one thing? Why not make it a promise? But for us, observables are really about how do I build more composable applications, more extensible applications. I already talked about the retry method, but there's another method that actually helps a ton with this, which is start with. So if you take an HTTP call, an observable that comes back from HTTP, and you say .start with, and then perhaps you have a local cached copy of the data that you want to be coming from the server, now my observable is going to emit two things. It's going to emit the local cached version instantly, synchronously, so that my UI can be up to date as soon as it renders for the first time. And then as soon as that HTTP response comes back, that data will transparently be rewritten for me, which is a really nice way of doing things that would be a little bit harder to with promises. If I had a promise of this, then what I'd have to do is I'd have to maintain some additional state somewhere, save that local copy, store it there, and then as soon as that promise resolves, rewrite that data back. And so this is something that you're going to see kind of over and over, is the operators that are available to you and the way that you can combine different asynchronous functions with observables makes them far preferable to work when I build and scale and architect large applications. All right, so I'm going to jump into some live coding here. So what are we going to do? We're going to do the traditional instant search or autocomplete. So I'm going to build a basic application from scratch where I'm going to type something at the top of the screen. And in this case, we're going to do a search of GitHub repositories using their GitHub API. We're going to want, our success criteria here is we don't want to be triggering another network request every time the user hits a key, and we'll actually build it that way to start, and we'll see why that's bad. And we also want to avoid something called out-of-order processing, where maybe one of my responses that I sent later comes back first, and now my data is stale and out of date. So I'm going to jump over to the IDE here. And so what I've done, I've only done one step here, all right, where I scaffolded out a new project, and I added a couple dependencies. So I added Angular material. And the necessary animations library. And so this is going to look exactly like any new project that's scaffolded by the CLI. So I just ran ng new devoxx UK-RxJS. What it gave me was all of the editor configuration, all of the testing configuration, all the TypeScript configuration that I need, and then all the files that I really care about. Let me make this actually visible to you guys. Are going to be here in my source/app folder. And so you can see here, we've got the module. So this is the context that my application is running in. So this determines what directives are available to me, and then also what components belong to this module. And then you've got here a component. So this is just a relatively simple root component, and it has a single property called title. And then you've got an HTML page that goes with that actually renders out that title. And so let's go ahead and make sure that this works. So I'm going to go in my terminal, and I'm going to run ngserve. And if I'm still in the right folder, we should see this start to do all the transpilation, all the bundling of my application in this live dev mode. And so what that will do is as soon as I hit save on the right side, and I will forget to hit save at least one time in the demo, pair of Angular sunglasses to whoever points out a mistake as I'm live coding here, and automatically recompile, do the incremental rebuild, and then refresh the browser. So let's go ahead and see if that worked. So I'm going to pull up localhost 4200. All right, and we'll also pull up the dev tools here. All right, app works. So we have a working Angular application. Woohoo, that was easy. All right, so let's rename this application Instant Search. Save that, and we should see this live reload. So now we've got Instant Search. So the first thing I always do with my Angular applications is I add material design, because when I build applications, they look terrible. Material design helps me make less terrible applications. So what I'm going to do is in my module here, I'm going to go ahead and import two things. So I'm going to import material module from Angular material. And then I'm also going to import something called animations. So in version 4, we actually split out animations. So if you don't need them, you don't pay the extra 37 KB. It's platform browser animations. Browser animations module. All right, so we've got those two ES 2015 imports, and now let's add them to our module. So we're going to add material, and we're going to add browser animations module. All right, so now we've installed material. Everything should work, but in order for it to actually look okay, I'm going to go ahead and add a very simple CSS reset style sheet, as well as pull in a default theme here. So I'm just going to go to my styles.css file. I'm going to paste these in. So you just see I'm resetting the margins, and I'm adding some margins back to some specific elements. So that means if we go to our component HTML here, we should actually be able to swap out this H1 with an MD toolbar, for example. And I'm going to set the color equals primary. And you can see I actually have something called the Angular language services, which I highly recommend installed. So what this will do is this will give me type completion based on a component-aware model. So it knows that this component owns this HTML file, and this component belongs to this module. And because this module has material design, I'm going to get all of the material design components automatically for me here, based on all of the setups and all the configuration I did in the module. And you can also, for example, get all of the properties that exist within your component. So if I say title, it knows that that's a property of my component and can do type completion. And it's also type aware. So if I have some complex object that I'm trying to get into, I can actually see all of the properties of that object. All right. So if we save this and we take a look, all right, instant search. It looks a little bit better here. Let's make it bigger. All right, perfect. All right, so in order for us to have an instant search, let's make a section here. And then I'm going to put at the top of the section, I'm going to put a input box. So I'm going to use material design here again. And then I'm going to say input of type MD input. And let's give it a placeholder of search, a type of search. And then let's give it a model. So I'm going to use the banana in a box syntax to do both property binding and event binding for our ng model. I'm going to say search term. And then I'm also going to add an event called ng model change. And I'm going to say new search, and I'm going to give it the search term. And then I'm going to finish out my HTML here for the section for the MD input container. And we're seeing errors here. That's because we actually didn't write those methods, and that property doesn't exist on my component yet. So let's go ahead and add that back here. So we should see, I believe it was search term. That's what I called it. Oops. Yeah, search term and new search. So search term is just going to be a string that we're going to store locally on our property. You almost got me there. And we're going to create a method called new search, and we're going to pass in the term. And so the first time I do this, what I'm going to want to do is I'm going to want to use HTTP, and I'm actually going to make a request and get back a set of responses. So let's go ahead and import HTTP from @Angular/HTTP. And then what I can do is I can get access to that HTTP handle, that singleton that exists within my application, that was provided by the module here. You can see we've got HTTP module. I can get access to that singleton using constructor. And then what I'll say is I'll say public HTTP of type HTTP. And so as I talked about in the beginning, we're using the type that you use there in the constructor to actually know what to go fetch, the injector should use to go provide that. Because we said it's public scoped, it's going to automatically add that to the scope of this object. And so in new search, I should be able to create a new variable here called results, for example. And we'll say this.results equals http.get. And we need a URL from GitHub, so we'll just copy this one. And then I'm going to swap out Angular here for our search term. So I'm just using the ES 2015 template literal syntax. All right. And so as I said before, this should be actually giving us a observable of responses, so HTTP responses. And so we don't want an HTTP observable response. We actually want something a little bit more interesting. So what I'm going to do is I'm going to use both a RxJS map as well as an array map in order to get exactly the data we want very quickly. So I'm going to take this observable responses. I'm going to say .map response to response.json. And then from within there, I want to get the items property. Because I know that GitHub returns back an items property that has an array. Because I know items is an array, I can actually map each item. And maybe I just want to get the name of that item. So in this one very quick command here, I'm actually diving really deep into the JSON that's coming back from the server into getting items, and then I'm turning every items.name property into the results of the observable here. And so if we go ahead into our HTML and we actually take a look for results here, let result of results pipe async, so that Angular does all of the subscribing for us and unsubscribing. I should be able to say result. And this should just be the name if I've done things right here. So let's go ahead and take a look back at all that code that we just wrote and see what I did wrong. All right, so we've got a material design search box that looks kind of nice here. And then what I'll say is I will just copy the word Angular. And so the second I've pasted that in, I'm getting back a full response. And if we swap over the network tab, we're going to see, we should see one response here. That's a little bit too small. Let me know if you guys can't see that. All right, so we made a single request here at the bottom for repositories with Angular as the search term. And every time I hit a key, so if I just hit backspace here, every time I hit a key, it's instantly doing another search. And so because we're doing this all kind of in real time, every time we're replacing the results instead of using an observable, it's swapping out and getting rid of all the past data, and then as soon as the new data comes in, it gets rendered. So we see this flickering, which is relatively undesirable. And I also don't want to be searching every time the user hits a key, because both of these things will trigger me to actually exceed my GitHub limit, which hopefully won't happen during this demo. All right, so what we want to do is we actually want to refactor this and base it off of an observable of strings. So every time we get a string from the user, we want to do something with that, and we want to process that as a stream of data. So what I'm going to do is I'm going to import something new called a subject. So I'm going to say import subject from RxJS/subject. And so subjects are a subclass of observables that give you a couple methods that allow you to emit data when you want to. And so I will create latest search of type observable. Actually, no, I'm just going to say latest search equals new subject of type string. And then we'll construct that. All right, so we have this latest search. What I want to do is I'm going to refactor my new search to just say this.latest search .next, and we're going to emit that term. And so now we've turned what was a imperative set of results. So every time something changed, we would imperatively throw away all the old results. And now we've got an observable of those terms. And so we can actually move this up into our component, or into our constructor, because we only want to define this mapping once. So now instead of going and getting from the term, what I can do is I can say this.results is going to be this.latest search, which is an observable of terms. And then I can say switch map. And then I can say term. And then I want to return that same object we had before, so the same HTTP request with the same map here. And then we just need a closing parenthesis. So what did we do here? We took our observable of terms, and now we're switch mapping. So every time the term changes, we're returning a new observable, so a new HTTP response that gives us new data. And so what this does is, because this data is coming in as a single observable, we still can consume it in exactly the same way, but we can actually now make much finer grained control of what we want to do with this. And so I'm going to add 3 new operators. So I'm going to import RxJS add operator, and we're going to pull in something called, we probably need switch map here as well. We're going to add something called filter, which allows us to say only give us a subset of these emissions from the observable. We're going to pull in something called add operator debounce time, which allows us to say, hey, only emit a new value if a certain amount of time has passed since the last new value. And so this will allow us to batch up our key changes. And we'll also pull in something called distinct. And so currently, RxJS is built so that you can get this very small object. So you can get observable, you can get subjects, and then not ship the rest of RxJS into your bundle. But then I can add, as I want to, declaratively, all of these additional operators onto that prototype of that object. And so if I do this, for example, in another component as well, I can do the same imports. And the bundler is smart enough to know, hey, we're only going to modify that prototype once, so let's just go get all the things I need. One of the things that's happened recently is the author of RxJS 5, Ben Lesh, actually joined Google. And so we're working with him to look for ways of making the syntax more intuitive, as well as to support things like tree shaking so that you can just import all of RxJS, not have to worry about which subparts you're using at a given time, and still produce small, fast bundles for your user. All right, so we have this latest search was an observable of terms. So the first thing I'm going to do is I'm going to debounce it. So I'm going to say I want at least 500 milliseconds since the last change. And so if we just look at our experience now, the application will refresh here. And so as I type Angular, we're not going to see a network query until after 500 milliseconds have passed. And that allows me to make a bunch of changes, and I can just get all the typing right. And then we make a single request out to the server as soon as the user is done. Another thing we can do is say .distinct. And so what this does is this will only emit a new value if the underlying term has changed. And so if we look back here, and I type Angular, if I delete 3 characters and retype them, nothing has changed. And so we don't actually need to do another web request. And then the last one that's really easy to add here is .filter. And what .filter does is it looks at the item emitted by the observable, and then, as we saw with the router example, only emits values that match. So we're going to say item, and we're going to say not item, or maybe term. And so what this does is we're just checking the term to see if it's truthy, so if it's not an empty string, because we don't really want to be doing searches for the empty string. And so we're collecting all of the user inputs for about 500 milliseconds. We're making sure they're distinct and new, and then we're filtering them out to get rid of anything we don't actually want to search for. And so very quickly here, this is going to refresh, and now we've got kind of the right instant search box that is good on my good for my users and good for my API. So I type Angular here, I backspace across everything. The data is still there while the user is thinking about their next search. So that was the simple app pulling in live coding. I've got a couple more slides left, and then we'll get into questions here. All right, did we succeed? Yay, hooray, thank you. All right, so another really cool thing that I love using observables for is role-based access control management. Because what ends up happening is we build these fantastic applications. We've got lots of different types of users, and we want the application to look different to different types of users. A very common use case of that is, for example, I want my admin user to see an edit button on every piece of context, right? But it's not always just an admin user. Maybe I have 19 different roles and different permissions that are going to be expressed different ways in my templates. And so what I do is I always use observables to map this data. And so for this example, I'm going to use Firebase. So just like we saw before, Firebase has an authentication flow. So it's got a service. This could be any authentication flow that you have within your application as well. And then we've got a database to actually fetch data about our user. And so we're going to combine these two things using observables. And so what I can do is I typically create an auth.service.ts file, and I define the exact thing that I want. So when I think about observables, I always want to define what do I actually want to consume in my template. And so in this case, I want to say ngIf is admin, ngIf is user. And I want to be able to do these checks to see if they are either a visitor. If all these things are false, they're a visitor. They don't have any permissions. They might be just a user in my system, or they might be an administrator. And so by starting with the end in mind of I want this observable of Booleans, which is going to change whenever the user user logs in, logs out, or even if they change permissions in real time, that's the data that I want for the user. And then I can define these things relatively straightforward, combining that auth flow and combining that database by saying this.user equals authState.map. So we're taking an existing auth state that comes from the authentication service and saying, did I get something back? And if I got something back, I know they're a valid user. So once again, I'm just doing that double exclamation point to get the truthiness value so that I get out a Boolean. The other thing I can do is I can combine, as we saw before, the auth state, just like we did with the router, where every time the auth state is updated, so if the user logs in, logs out, we get a new observable that emits values from that user's permissions. So here we're actually checking within Firebase to see, does their ID exist in the admin's object? Because if their ID exists in the admin's object, we know that they're an admin. If it doesn't, we know they're not an admin. And what's really nice when you combine these things is that all of these things happen in real time. So if you have two users and you add someone's permissions, their entire UI is going to react. It's going to respond instantly because this real-time data is going to update. It's going to say, hey, I suddenly have a new set of data for that object, and now I can actually see that I'm an admin. That edit button will show up kind of instantly. So just to kind of leave you here, including RxJS is a really important part of developing your own personal toolbox. Right? This is something that doesn't solve every problem from a developer experience, but it can be very helpful, especially with the amount of data that we work with that's asynchronous continues to grow and continues to expand. Thank you so much. All right, I think we've got about 5 minutes left for questions. So if anyone has questions, I think there might be a mic floating around. Otherwise, I can just repeat your question.
Is it correct to say that we could systematically, or we should systematically use switch map when whatever function we're going to be passing to it would return unobservable as well instead of returning just normal data, and that's why we don't.
Yeah. Okay. So what it does is it flattens out this nested call, right? So you've got this call of when this first piece of the data changes, we need to go get the second piece of data, and that second piece of data is also asynchronous. It flattens it out and gives you just one observable that has the resulting data of both of those calls.
And then why wouldn't we just then use flatmap?
Flatmap, I believe the difference between flatmap and switchmap is that flatmap does not unsubscribe from past data. Right. So if my UID switches, I want to unsubscribe from the endpoint that had all of the data for that user. Yeah, there's something like 60 or 70 operators, so you can get the first item of an observable, you can merge them, you can merge streams, things like that with combine latest. You'll kind of, as you develop and as you learn more Rx, you'll just add one or two every few weeks, and then you'll get to a critical mass of, I don't know, 10 that are your kind of go-to observable operators, and that'll probably solve most of your problems. All right, any other questions? All right, well, thank you guys again.